Hi, I'm John Janowick. I'm the Executive Director of the Electrical and Computer Engineering Department Heads Association, and welcome to the Industry Spotlights. We're honored to have the next Spotlight session from Digilent, and it's on makers and learners. Clint Cole is the President of Digilent and is instructor at Washington State University. Clint?
Hello, and thanks. Put these on so I can see. And thanks again for letting me come talk to you guys. This is one of my favorite shows to come to talk to you guys. And my first slide sort of sums up why. It's going to seem like I'm pandering a bit, but I'm not. I actually believe this. How do I? There you go. And I believe that for a reason. So I believe that our students are the most important students. I believe that there's fundamental technical challenges that we humans have brought about that we need to solve, and there's no way to solve them but through better engineering. And you guys get to establish the policies and procedures that we employ to educate these engineers. So it's kind of a passion of mine, actually. A couple of points I want to start out with. First one is I've been an engineer for about 20 years, and engineering is fun. It just is. It always has been. I've always been thrilled, ever since the 80s when I started working, that people would pay me to go play, to build things, and to have fun. And in fact, my experiences have shown that to be true, not just for me, but for everybody I've ever worked with. It's when you're at work, I was at Hewlett-Packard, the camaraderie's there, the passion. People would work till 8, 9, 10 o'clock routinely, not because they were compelled to, but because engineering is fun. And we're starting ever earlier. There's all kinds of competitions out there that encourage our youth to get involved. They make competitions out of it, like a football or basketball tournament, and there's just a lot of interest and a lot of activity. Most of us now are doing introductory hands-on engineering classes in the first semester or first year at school, and they're popular, and that's great, and that brings some of that fun back to the program, and it kind of extends the activities that people are now involved with before college. The FIRST program, the Lego League, and all the other competitions out there. That's all good stuff. But then they get into university. And when they start taking labs, this is certainly the case in my experience, we pack them in labs, we give them recipes to follow, we give them a specified time, we give them fixed equipment that can't leave the lab. We incent them to stay on task and get done in the 2 or 3 hours, and expect that in that time frame, if they just do the recipe, that they're smarter because of it. And we, in effect, de-incent them to take time to explore and to play. And there's peer pressure. You don't want to expose, it's been a while ago, but I still remember sitting in lab with some guys I didn't know very well, and I didn't want to expose my weaknesses. I didn't want to be the weak link on the team, so I just nod a lot and point and watch, and occasionally I'd push buttons and hook things up, but it was sort of intimidating. And then we do this every week to them for a couple of years. And I wonder what we're suggesting in that environment. That conformity and obedience are the skills they're going to need, that the creative processes can be quantified and they're well defined and we know when they're done, that you can measure design and creativity against the scale. And mostly I wonder, when they get out, do they expect that engineering will occur in that kind of a sandbox? Now, I've hired lots of engineers over the years, and that's one of the bigger hurdles to get them over, that there are no set answers. There's no prescribed way. There's nobody at the company that can say, yep, you're done, that's good, press on. It's an open-ended, continuous thing, and we need to give people the skills to survive and flourish in that environment. And I'm not sure the recipe-based sort of sandbox we're presenting is the best thing there. Then you guys, you got to schedule labs. You got to make sure PCs work or try to buy new ones, and that's always a challenge. You got to make sure the tools all work, that the student accounts are good. There are a whole list of things that you have to do that really aren't involved with teaching, but they have to be done. Somebody's got to do them. Well, I think there's a better way. And I think we've demonstrated that, and I want to tell you a little bit more about how we're approaching bringing that better way to boot. Well, first of all, one more point I want to make, and that is that makers are learners. We all want to build and create. That's why we did this, and that's why the FIRST programs and the out-of-college experiences are so popular, because people want to build. You know, people, over 1 million Arduino boards have sold now, over 1 million Raspberry Pis, and those are going into hands of people who just want to build because they enjoy it. I've learned in about 10 years of doing this that makers are learners and learners are makers. And if we give them the tools they need, they'll use them. We don't even have to require that they use them, they just will. And if we encourage them a little bit to explore and incent them that that's on their path to success, they will explore and they'll discover and they'll build and they'll ask me questions I can't answer, which I still find fascinating after this many years, that somebody in their first 2 or 3 weeks can have insights that have eluded me for 25 years. I think all we have to do is to incent them, to guide them, and to encourage them, and they'll get excited. And they'll start challenging us. Clearly, active learning works. I think all we have to do is encourage them, the students, to build lots of real systems. Now, simulations are great. I mean, they changed the way we were able to educate many, many years ago. But we can do better now. The endpoints of simulations, of course, are assumptions. They're models. They're not real physical systems. And so much learning happens in that last little bit of an implementation when you go from a simulation to an actual physical system. We want to invite curiosity and encourage it, and encourage them to explore and to stop and dwell when they need. We don't want to have them just rush through those projects. When they do that, they build self-reliance and self-confidence, and they can learn modeling and simulation at the same time. Now, the key, I really think, are design kits students can use anytime, anywhere. Not to rush them into lab and rush them back out, but to give them the tools to work where they're comfortable, when they want to. And it works. I've shown this slide before. Oops. Where'd it go? Well, you've already seen it, or a lot of you have. That we did some studies years ago proving that if we just gave students design kits and did nothing else, just gave them the kits, they improved their outcomes. Didn't even require that they use them, but they played with them and they used them to learn. They were self-motivated. Now it won't go the other way. There we go. So I think all we need to do is put these kits out there. We've got to put out kits that students could use, that every student can use all the time, whenever they want to, that are low cost, powerful, self-contained, and we've got to back them up with high quality and freely posted design projects and examples and tutorials, and a lot of us are working on that right now. You know, it seems week, there's dozens more of these projects and sort of tutorials and guidance documents posted out there, mostly by faculty at your schools, and that's great. We need access to online course and educative materials, and that's rapidly happening as well. And then we need to have an effective back end, a place students can go to get help when they need it. So at Digilent, we produce design kits for these 3 areas, and they start, in the digital case, at $49. That's not a lot to ask of a student or of a department. On the microcontroller side, they start at $26, and on the analog side, $99. And all of these are very capable kits. They all feature, I think, the best available technology at an incredibly low price. And you can do all kinds of things with these. On our digital kits, you can literally implement processors from scratch, MP3 players, video games. On the microcontroller boards, that's a 32-bit, 80 megahertz processor, plenty of power to do any kind of controller that would make sense in the first couple of years of education. I'll tell you all more about these here as we go on in the next couple of minutes. Well, quickly for analog design, that's been the tougher challenge. You need a lot of equipment to effectively test and measure circuits you might produce. And that's some of it there. Of course, that costs a lot of money. And they're big, and they take a lot of power, and they've got to stay on a bench in a lab somewhere. Well, last year we came out with our analog discovery that replaces that equipment and can be used anytime, anywhere. It's USB powered, and it's got all of those instruments. In fact, it's up to 9 instruments now. Analog inputs and outputs, logic analyzer, spectrum analyzer, that's new for us. We've beefed up our network analyzer, power supplies, voltmeter, digital logic trainer, everything a student needs to test and measure analog circuits of all kinds. And it fits in their shirt pocket, and it's low power, it's USB powered, high-speed data, easy to get files in and out to make reports in Excel or Word. We designed it to be sort of the ultimate student analog design tool. It's got all the software that comes with it for free. I'm not going to go through all this, but it's got oscilloscope software, waveform generator software, logic analyzer, pattern generator, all the tools you'd expect to find on an engineering benchtop. Network analyzer. This is the new spectrum analyzer. And there's the price, $99 for students. I think it's an incredible deal. 14-bit, 100 megasample converters, good performance. Yeah, I think that everybody should have one. And if you guys want one, come to our booth. We'll give you one. Everybody here. Hopefully you'll take it back and use it and maybe give it to some other faculty members. We put together a parts kit that's got some of the best ICs we could find. It's got 20 ICs from Analog Devices in it. It's got all kinds of sensors, all kinds of semiconductors, a lot of discrete components. Everything a student needs for the first couple of years to build all kinds of engineering projects you'd find in Circuits 1 and Circuits 2. $49. The parts alone cost far more than that. We get help from industrial sponsors to put these out there so students can take advantage of them. And you guys should take advantage. You want one of these? We'll give you one. For this one, you have to go to the Analog Devices booth tomorrow, and they're going to be handing them out. One for everybody. Two if you ask nice. We have microprocessor and digital design kits. They're all low cost, powerful, they're all USB powered, they're all self-contained, so students don't need to buy anything else. They're all backed by lots of projects that are freely posted on the web right now. In fact, you can get the sources for them. You can take my name off and put your name on if you want to. I'll even help you do it. And we have good support for them. Have a range of these things from $49 up to $200 that have bigger gate arrays, bigger processors, that kind of stuff. And we just came out with our Nexus 4, which I think is our best yet. It's got Xilinx's brand new Artix part on it. Lots of memory. You can run Linux on this thing. You can make full computers. You could run the software on this thing that you'd use to program this thing, which is interesting. Lots of materials for it. You want one of these? Come to our booth. Now, we don't have them yet, but we'll ship them to you. If you guys come and ask nice and let us bug you for a few minutes, we'll send you one here in the next couple of weeks. Well, I shouldn't, next month when they're done. We just got the prototypes back. They work. We're just starting manufacturing now. And then we have a lot of microcontroller kits as well. Again, starting at $26. That's our chip kit board that's got the Arduino IDE, very simple to use, very popular in introductory programs, all the way through our Cerebot line. I'm sort of featuring the MX7 today. This is a microcontroller board with, well, you can see the specs there on the part that's on it. But it's got the chip kit front end, so you can run the Arduino IDE. But it's also got the programming and debug circuit for microchips, so the same exact board can run the MP Labs software. So you can go from a very simplified environment to a very sort of industry standard professional environment. Everything you could ever want to do with a microcontroller board, this board can do. It's got all the ADDs and timers and interrupt controllers and stuff to teach students how to live in that environment. Want one of these? Again, come see us. Let us know who you are, we'll send you one. These are in stock now, so you can get these in a week or so. So to kind of finish up, student-owned design kits. World-class technology, low cost, free tools. It's better for students. It just is. They learn better and they like it. It's better for your staff. They're always current, there's no hassle. The materials posted on the web are free, they're low cost. We iterate them as technology changes, so you're always current. We've proven the effectiveness of them, and they're available right now. They work. They make everyone's job easier, and you should use them. That's it. Thanks.